So here for 58, 59, and 60, we're looking at the central limit theorem. So a sample of size 95, n is 95, that's the size of the sample, will be drawn from a population with mean 25, standard deviation 13, and we want the probability that the means will be between 22 and 27. So we're drawing a sample of size 95 and we're checking the mean of that sample. And we want to know the probability that that mean will lie between 22 and 27, given this information. So the central limit theorem formula, is in your formula sheet, and it says Z equals x minus the mean, just as we start off with before, but divided by sigma over the square root of n. That's the only difference. Instead of just dividing by sigma, we divide by the square root of n as well in that denominator. So for each of these x values, for each of these x bar, these mean values, this should be x bar, sorry. X bar minus the mean. My apologies. So for each of these x bar values, let's convert them to z-scores. Right, so let's start with 22. So 22 minus the mean over 13 divided by the square root of 95. I'm just going to put that into the calculator for the ease of it all. So we've got 22. Let's put the numerator in parentheses. So let's just type it in. 22 minus 25 divided by, put the denominator in parentheses, 13 divided by square root of 95. So that z value is negative 2.25. Negative 2.25. And I'm going to do the same for the z value of the x bar value of 27. Divided by 13 over the square root of 95. So this z value equals, let's pull up this calculator again. So second entry, so I can just have the values back, and now I just change 22 to 27. Haha. Nice, right? So that's 1.499, so I'll round that to 1.5. The z value is 1.50. So just as I did before, I'm going to look at the table again and find the probability that z is between 1.5 and negative 2.25. So I want this in here. And again, the way that I do that is I find z of the probability that, or the area under the curve less than negative 2.25, or the probability that z is less than 2.25, find the area under the curve less than 1.5 and subtract them. So the area here equals the area here equals, and then subtract. So negative 2.25. Negative 2.25, that's my z value, 0.0122. 0.0122. 1.5, that's z value, 1.50, 0.9332. 0.9332. So 0.9332 minus 0.0122 equals 0.9210. There's the probability that our mean will be between 22 and 27.9210. I'm doing the same for 59, the same for 60. So 59, a sample of size 39, so n is 39. Will be drawn from a population with mean 23 and standard deviation is 10. Okay? So find the probability that x bar, the mean of the sample now, right? That's the sample mean, will be greater than 25. So z equals x bar minus my mean. And of course, we know x bar is 25. That's the sample mean. Divided by sigma over the square root of n. So z is 25. That's our sample mean that we're interested in. Minus the population mean over sigma divided by the square root of 39. Again, right in the calculator. I'll type it all in again this time so you can see it. So open 25 minus 23. I could just put 2 there because I know that's 2, right? Divided by, open parentheses, 10 divided by the square root. That opens another parentheses, square root of 39. Closing both. 1.248, which rounds to 1.29. 1.25. I was about to do it again, huh? So I want the probability that x bar is greater than 25, which is the same as the probability is that z is greater than 1.25. So that's going to be 1 minus something, right? Greater than 1 minus. So let's look at 1.25 again. 1.25, 0.8944. So 1 minus 0.8944, 0.1056. That's the probability that x bar, that our sample mean, will be greater than 25.1056. Same for 60. Sample size is 47. Population mean is 25. Standard deviation is 5. Population standard deviation. The x bar we're interested in is 26. So z is x bar minus the mean divided by the standard deviation divided by the square root of n. So x bar is 26 minus our mean of 25 over 5 divided by the square root of 47. You know where that's going. 26 minus 25 divided by 5 divided by square root 47. 1.371, which rounds to 1.37. So the probability that x bar is less than 26 is the same as the probability that z is less than 1.37. Just looking at the table right away, straight away. 1.37, the table gives us less than 1.37, 0.9147. And we're there, 0.9147. And that, folks, is it.